Hello everyone. This is another video of demonstrating my projects, and in this video I'm going to demonstrate my microservices project, which is story loom. And this over here is the basic architecture of our project, but we will take a deeper look into this after the demonstration. So this is our project. It's an AI-based books and movies recommendation platform. We can get recommended movies or books which we have read in past or with our interests. Over here we have basic authentication. There we can create a new account, but I already have an account, so I'm just going to give my username and password. If I forgot the password, I can reset it. After login, we can use all the features in this website. If I go to browse, I can get trending movies. These are trending books which are fetched from API, Open Library API. So these are weekly trending books. These books are trending this week, and they get refreshed every week. And do same as for movies. These are trending movies for this week, and and these movies are being fetched from TMBD API. We can see over here there is a rating and a small description of these movies. This is being done by catalog service. And if I go back to home and here, I can get recommendations of books or movies. Let's say I want recommendations for books. I will give my history of books which I have read, like Clean Code or something. I can give multiple movies, multiple books, but for now I can just give one. And I can select over here what I'm in mood for, and it will recommend me books on based on that. So let's just say this. So this is calling Gemini API, using Gemini's API for all these recommendations. So we can see what AI has recommended for us, the programmatic programmer refactoring. The Gemini API only returns the names of the books, and this data is fetched from the open library. After that, we will take a deeper look at the architecture. Then we will understand how this is working. So here, same way we can do for movies as well. And also we have option of communities over here. If there are any rooms available, discussion groups, they will appear over here. Right now there is none, so I will create one. Let's say Zykes room, and give some description, great chat or something. We can see the room has been created. We can see members who have joined this room. People can join this room and stay part of it. Here is the description and creation date. This uses WebSockets, so this chat is real time. If I write hey, so everybody in this group will get this hey in real time because it's using WebSockets. So I can also delete this community or leave this community. Only owners can delete this community. If I'm the owner and if I leave this group will be deleted. People can join by room ID, which people can share with each other. And also the login and logout system over here uses JWT verification. And when you sign up, you have to give your email, and an OTP verification takes place. After that, you are given an access token and refresh token. Access tokens expire every 15 minutes, and refresh tokens can be used to uh, get new access tokens every 15 minutes. Now let's take a look at the architecture of this project. We will also take a glimpse on the code as well. There are these four microservices. Eureka service registry. It's also a different Spring Boot project, and there is API Gateway sitting in front of them. So there is auth service, AI recommendation service, catalog service, and community service. Auth, catalog, and community have their own Postgres databases for storing the user data, storing the books and movies data, and also storing the rooms and members, message, all that data. So all of these are API Gateway, and all these four services are Eureka clients, and they are all inside this Eureka service registry, and they are all registered in the Eureka server. This Eureka server is used for service discovery, so they can find each other as well. So inter-service communication happens through OpenFang. The client will send a request to API Gateway, and if the client hasn't signed up, the API Gateway will route the request to auth service. Auth service will register the user and store in the database, then provide the access token and a refresh token, which will be given to API Gateway. So next time the client will send request, API Gateway itself would validate the refresh token and route the request based on that. The auth service also has OTP verification, so that's also stored in database. And AI recommendation service uses Gemini's API to get recommendations of books and movies. After the Gemini API suggests some names of the books, those names are given to catalog service, and it will get the details of that book back to the AI recommendation service, and then it will be given back to the user. Now the community service over here has lot of rooms, and inside those rooms lot of people are chatting. So if we save each message in the database, the chat will become slow instantly. In between the community service and the database sits Kafka. So every time someone sends a chat, that chat message is queued in the message queue of the Kafka. Then from the queue from that queue, the messages will be stored in the database. So community service does not slow down. It does not wait for database to save the message and then respond back to the user. It just queues up the message and then goes back to whatever it's doing. This makes the chat faster, and as we all know, Kafka helps us with high throughput and fault tolerance. These features transfer to community service, and all of these services, all of these database and Kafka as well are Docker images which run on same network. So same, we have to keep it same network because of the Eureka server. So these services can discover each other. Now, here are all the services. These are different Spring Boot projects. So here is the service registry itself. It is a Spring Boot project. API Gateway also is a Spring Boot project, and this is the front end of this project. So all these services and databases, I have created a Docker container of those. These are this is the auth service DB. Let's start this container. It is catalog service DB. Start this as well. It is community service DB. Start this as well. So all the databases have started. This is Kafka. It's also a Docker image. Let's start this as well. It's running in K-Raft mode. Now let's start the service Eureka service register. So after this starts, I will start all the services so they can register themselves in the Eureka. Here is the auth service. Let's start this one. It is catalog service. Start that one. Community service and recommendation service. Start all of these. After these are started, I will start the API gateway. But before starting API gateway, we have to make sure all the services are running. So after this, I will start the API gateway as well. All of these containers are running in same network, which is this internal. We can see this internal network is running all these services. So this is important. They have to be same network because the Eureka service registry has to discover these services. So if I go to service registry over here, it is running now. If I go to localhost 8761, it's running the Eureka server. And we can see over here all the registered services, their instances. They can have multiple instances, but for now there are only one instance. There is AI recommendation service, API gateway, auth service, catalog, and community service. All are registered over here, and this means they can discover each other and they can communicate with each other using OpenFAQ. So now this is the front end of this project. I have not built it, my friend has built it, and so I'm just going to run this project. npm live dev and go over here. We can see we have got the URL. Now I will paste that URL over here, and we can see we are running our project. I'm logging, see if it works, and it works. Thank you for watching this demonstration. If you want any more details or want to dive deeper in this project, there will be a GitHub repository link down in the description, and there is also my LinkedIn profile as well. So feel free to contact me if you have any question about this project and want to learn more about this project. Contact me on my LinkedIn, and maybe I will give my mail as well. You can mail me as